I am working right now in NetWest Group as an engineering lead for, sorry, as an engineering lead for NetWest Group. I still get a lot of background noise. I don't know from where it is. Hello.
Ma'am, everyone is mute. Wait a second.
Some very strong. Yeah, it's better now. Yeah, thank you. Okay, so my name is Neha. I have been working as an engineering lead right now in NetWest Group. I work in investment banking side as of the moment. Over in my last 11 years of career, I have been moving and working towards in different streams. I have worked on retail side, I have worked on payment side. We have evaluated SIFT and other systems and made implementation of analytics from there. Then recently, in last 2 years, I've been working on the trade side. So I'm a part of a client technology trade team. Our job is to evaluate and do data engineering and data science for trade products data. The clients and the customers who deals with trade products, FI, FX, and any other currency related products. So you evaluate those things, analyze, maintain data warehouses, maintain data engineering discipline, and get some predictions and interpretations out of those data by ML. So that is our day-to-day job as of today. That's what we are doing. What I'm going to do, see, my assumption with this session is that we are trying to do something, understand from a practical perspective that how those things happen inside, how the actual work happens. Because when you go by an online course, okay, that learn how to do machine learning, that course is very restricted in nature. So that is a very small part of machine learning. What I want to discuss, and I would like to keep this session as much as interactive as possible, and you can ask anything which comes to your mind. So what I will try to dive in is that what all comes as overall machine learning implementation when you go in an organization and try to implement those things, what all components are involved, how things get initiated, how things an end-to-end cycle, that how it works, why we use that, how it is happening, and not just writing a model. Why Python is a skill which students can incorporate, or you can incorporate in your curriculum and later on, or whatever you prefer. There are so many things which comes associated with machine learning. It's not just going and reading a data set in Python and just implement a model and that's it done. You can add much more value if you understand how an overall perspective it works. So that's my agenda of next 2 hours, to give you that picture, that how essentially it collaborates and coordinates with other things, and what all are the practices and challenges which we face on day-to-day basis. So in any moment, although we will have a Q&A session in the last, but still if at any moment you want to ask questions at that step, please stop me there, raise hands and ask questions, no issues. Ask as much you want to ask there. So I will not focus more on PPT. I will try to keep it interactive if you guys also want to do it that way. But still, let's go ahead and understand it from that perspective. So if I... The topics which I'm going to cover today. So the first thing I want to focus on is how exactly this works, how it gets initiated. I mean, it's not like that someone will come inside and start writing Python code, right? So what works is, the first thing for any organization to do to implement an ML use case is the problem statement and use case defined. And why this step is important. See, there are so many things for which you can predict, or you can evaluate, or you can bring outcomes. But you need to understand that there is a big effort and investment goes even in generating one model. Okay, so you will have people from data engineering working on it, you will have a data scientist working on it, you will have other folks working on it. So it takes a lot of investment to get that model right. So you want to make sure that your use case is worthy enough. It's worthy enough that it's solving some problem. We need to understand what we are trying to assess, how the business impact will be measured. So if I am saying, if I take one use case, that I want to know and I want to predict that these customers are going to buy a credit card if I approach them. Okay, and I want to know that so that I approach the right people who will take that credit card, purchase that credit card. Then What we are trying to assess in that is, I am trying to predict that this particular customer will take a credit card, so my salesperson can reach out to him or her. The next thing in initiation we need to think about is, if I am trying to pursue this use case, then what data I will need to assess that this customer will buy a credit card or not. Okay. Or if I talk about fraud detection, or if I talk about credit scoring, or if I talk about interest rate, any scenario we take, like if I take the recent scenario which we have been working on, so we have email suggestions going out to customers who do trading with us. Okay. We send them trade ideas. Right. Now, what we were trying to evaluate is, if I'm sending these trade ideas to 100,000 people, how many of these people are my targeted customer who will actually invest in that trade idea? So, how we try to capture that gap is, we assess and record that when we send that trade idea, how many people read it, okay, or how many people spent how much time on it. So that tells that they are interested, or they are interested in that particular topic, or those things. So those things are captured, and other factors like at what time that trade idea was sent and those things. So all those things are think in the initiation state, in the respect how much business impact this will be done. We cannot create an ML model for every use case. We have to be specific for that this is bringing some business value. What we are trying to assess with it, what is a target outcome. We can't just go that today I'm getting this problem, let's create an ML model for it. No, what outcome I'm expecting and what evaluation metrics I will use. So these discussions, these evaluations, these brainstorming is the first step which happens practically in an organization. Okay, now this is one thing. Two things before we get into the steps which are involved in a machine learning execution end-to-end flow. Two things I want to highlight here and make understandable is, see, we have to understand how things have moved over the years and what we are trying to do now. So I am not sure what has been covered till now in the program which has been running from 7. And if all of this has already been covered, then I can skip it. You guys can let me know. What I'm trying to explain here is that if we go back to when we were actually just entered into the industry, at that time we were working on data lakes and data warehouse. Okay, so a simple concept was that we get data from different systems, source systems. We put it into a warehouse by doing ETL, and over that warehouse, reports are being generated. That was the traditional approach, which was working previously. Now that has changed, and that has also changed over time in last 10 years. So now we no longer have a concept of separate lake and maths. We have a singular entity in between, okay? And over that, we are trying to reach all aspects of the end user. That is, we are trying to do machine learning, we are trying to do data science, we are trying to do streaming analytics, and we are trying to do BI reports as well. Okay, and this includes structured and unstructured. Unstructured is also getting really popular and useful these days. Now coming to machine learning, as I was saying that machine learning is not just model creation. Okay, it's not just creating a model and be done with it. It has to work closely with other principles as well. So when you do machine learning, you have a very big component of data engineering involved in it, because your raw data will be captured. You will, so let's say today if I decide that I want to predict the that which customers will likely be interested in my trade idea. Okay, then what I need is, I need the data of trade, I need the data of articles we have published, I need the data of clients we cover, I need the data of salesperson we cover. So all those data has to be first onboarded. You will have to build pipelines, whether those are streaming pipelines, batch pipelines, depending upon the requirement. That data has to first come in warehouse, pre-processed, and so many other things has to happen, and then your model will be built. So that is all part of data engineering. And even after when your model is built, then you will be interacting with new serving data. So that is also coming from a module which is maintained by data engineering. And once your model is built, after that, how that is executed in production, how the pipelines are generated, how you can migrate or take the same package model in from one environment to another environment, that is come under ML ops. So machine learning is part of that entire ML engineering which we are doing, and it incorporates and closely work with other things. So it's not just an independent component. There are so many skills which comes together to get one model live. So the interest area, if someone wants to get into machine learning, the interest area can be amongst any of these skills. It does not necessarily have to be just writing models. Any questions in this? Anything you want to ask? Anything you want to know?
Oh, yes, ma'am. From audience side, one participant asked, "What is ETL?"
ETL is basically extract, transform, and load. So what happens? What happens is you will hear two words in industry. One is ETL and one is ELT. Okay. ELT is extract, load, transform, and ETL is extract, transform, load. The difference is when you do ETL, you will extract the source data, you will apply a transformation, and then you will load it. So if I explain it to you, so let's say you're doing ETL. Okay. If I talk about ETL, okay. If you're talking about ETL, then you will be extracting source data. Let's say this is your source system, okay. You will extract this data, okay, and then over that data you will apply transformations, and then you will load this data, okay. So what that mean is that you did not loaded raw data, okay. You pick the raw data from the source system, you applied some transformations in the picking mechanism. So let's say you created some programming job to connect to a source system, pull data. After you pulling your data, you're applying transformations there directly, and then you're loading data into your warehouse. Whereas the second popular approach, which is being very popular these days, is ELT. Okay. What does ELT do for you differently is, in ELT, you basically first extract, then you load. That is, you loaded the raw data from the source system which you extracted, and now whatever transformation you want to do, you will do in your warehouse. And the reason, so see, in last 10 years, if you talk about 2008 to 2011, ETL wasn't very high, it is the only approach. And even today, ETL is very popular. But later in the years, people have started in design engineering practices, people have started going with ELT. The reason being is, if you go with ELT, then you don't have to investigate that what data got lost or what data transformation happened when the data was extracted from the system. You simply load the raw data in your warehouse, and then it's easy to manage and cater or basically debug and troubleshoot those problems if you face any with that data. Otherwise you will have to go back to source system and get those things sorted. So both of these approaches are equally popular, but we as a design engineering practice, we have started going with ELT until and unless ETL is required at any scenario. So ETL is done in the data warehousing concept to transform. So if I go back to this image in which we have mentioned ETL, see, you will have to, so let's say if I'm talking about net banking, you all use net banking, right? In net banking, when you go and you, let's say, do add pay, okay, and you transfer a payment to that pay. Now that is a transaction system. That is an OLTP system. The database behind that net banking system is OLTP because you want fast responses. You have to have close nitty-gritty between different tables, that if a person has added a payee, then that payee has to be visible this, and that payee can have multiple transactions accordingly associated with it. So those are OLTP systems. Now if we want to do analytics over that data, that what kind of payments a business is transferring or what is the overall turnover of that business and stuff like that, we will migrate that data to a warehouse. And when we do that, we will do it by a process ETL or ELT. Because if we will start using data from different end user systems, then it will slow down those systems as well, and we can't do analytics because those are straightforward systems. Now I may want to join that payment details with another data set, okay, and evaluate some other analytics. then I need those data sets combined at one place to use that. That's why we create data warehouses. Data warehouses are created by using the entire bank's data publishing into from different source systems. This is done for many reasons, but one of the primary reason is that your end net banking and end apps and everything, they are OLTP systems. We can't use them for streaming analytics or any kind of analytics and warehousing. We have to create separate data lakes for those. Does that answer? Hello?
Ma'am, further he asked, is ETL transform same as cleaning the data?
No. Not necessarily. Not necessarily. So ETL transformation could be also doing some transformation. Let's say you have a variable 1, you have a variable 2, and you want to join and create a variable 3. And then you want to load it as variable 3 in the data warehouse. So that is also a transformation. Or you want to apply a case when statement that when my trading product is fixed income, I want a new KPI that this is a fixed income product. And when my trade product is, let's say, FX, then I want to apply something else. So this is also known as transformation. Or I want to join my payments data with counterparty data I have in bank, and then I want to do some transformation. So transformation is never essentially only cleaning the data. It could be anything. ETL can have any kind of transformation. Usually people have stopped doing those transformation while loading data to stage, but it does not mean that they are only doing cleaning. It can include anything. So these transformations you may have heard happening traditionally via SSIS packages, different autosys jobs, and even Oracle OWB was a very popular tool at its own time. Even today, traditional companies are using those. But right now, everyone is moving to cloud. So we have a different ETL strategies there. But uh, to answer your question specifically, it's not same as cleaning the data. It includes cleaning the data, but it can have other transformation as well. Okay. Okay. I will come back to this image. Okay. So I will go step by step of machine learning model, how it works and pipelines, but I will come back to this because I want to highlight, and I would have loved that as a student back then in my time, that there are so many things which you can add from the perspective of a student, that these things are significant as well from machine learning perspective. So I will come back to this slide. Let's do this one. Okay. So how a actual workflow, what does it include in machine learning? The first step, sorry, my mouse. The first step is always use case understanding and experimentation. Second is once we have understood our use case, we will process and prepare that data related to that use case. Third is on that data, we will train our algorithm. After training our algorithm, we will evaluate our model and we will test it. After that, it will go through model governance. Then we will deploy the model in production or any target environment which we have to. Then we will build pipelines for its execution and orchestration. Then we will do continuous monitoring and logging. Why it's moving so fast? And then we have, then we have a feedback loop. I don't know why this time controls and balance. So if we look at this overall in real case, to take a model live in any organization, if I talk about banking right now, these are all the steps which includes, and please mind that these steps are not sequential as it is. So they are sequential in the first time, but these steps overlap each other a lot. Overlap in the sense that after you have collected the feedback, this feedback will go back to again model training, and it will retrain models and it will reevaluate. When you are doing continuous monitoring and logging, that will that monitoring will also evaluate your model on the runtime every time. So all of these steps are basically talking with each other at multiple times. Like when you're monitoring and you observe that some other data is also throwing some impact, then it could be the case then that you need to do some more data pre-processing and preparation. So all of these steps get revisited as an outcome, as a continuous, you can say, orchestration of that particular model. So everything, the first time, obviously it's a sequence, but then all of these steps come correlated, and this include people from at least three streams involved in this. So it includes data engineers, because all the data portion, data availability, data pipelines, that will be built by data engineers. It includes data scientists, because a model training and evaluation will be done by data scientists. It includes governance team, which will own the model from a business perspective, which will evaluate the outputs, which will keep track. So let's say if I create a model today for credit scoring, and somehow next few months, 6 7 months, something new is added as a product in the bank, like these days cryptos are coming up and so many new things, or new product is launched, then model governance team takes care that if anything new needs to be added to the model or not. And similarly, there is a sales team. So it includes a lot of teams, a lot of people to get a model successful. If I am building a model to derive that this customer, if I will call this customer will purchase a credit card, my probability is 80%. Then to run that call, I will need a salesperson in the end. And that salesperson will be the person who will enter the feedback. So a single pipeline, a single model includes a lot of discipline, lots of roles and lots of responsibilities. So it's not just only data scientist. Okay. Any question in this? We will go through each step in detail, but
No, ma'am. No question.
sorry. Okay. Sorry. Uh, okay. Okay. Then let's talk about first step. So when I say use case understanding and experimentation, the use case whichever we are picking, okay, this will always come from business or governance team. It should have a business value, and it should have some business value which is actually countable in numbers. So as I said, that it takes a lot of effort to run this complete end-to-end pipeline. So your use case have to be profitable. Okay. We have to also look at that the use case I am targeting, I have the data for it. If I don't have the data for those use case, it could not be any hypothetical use case. It has to be a use case for which the data is available so that the conclusions can be derived. The third important point is looked into, that what is my accepted margin of error. If I implement this use case and this model give me, let's say, credit scoring has a very low accepted margin of error. If a credit scoring model evaluates biases. So think about it. You're going in a bank and you're applying for a loan. These guys run credit scoring model to evaluate whether this application is good to go ahead or not. Okay. Now those credit scoring models, if they are biased towards a customer who is basically applying for a loan, then it will be, a negative for a customer, that there is some bias related to female, male, or other things, or maybe somebody having two children or less job and something like that, somebody's bachelor and all those things. If model has those kind of things, then it is a negative point for customer. Now if model is biased towards customer,
Sorry, ma'am.
then it
Sorry, ma'am. Sorry, ma'am. Sorry to interrupt you. Ma'am, someone says increase the size of slide. Maybe
oh
it is
sorry
not visible for you.
okay, sorry, actually some issue with animation, that I was not increasing. Okay.
No issue, ma'am.
Now, okay. Now if the model is biased towards customer and giving wrong information to bank or predicting wrong information, then bank may end up providing loan to someone who cannot pay it back. So each in every use case, these kind of things are talked about first. That what is my margin of error from this model? How much error I can accept from this model? Okay. So some very popular examples which we do in the bank is one kind of models we create for targeting sales, whether it is a product. So if I talk about a very generic example which you all use, like if you all use Amazon. So when you navigate through any product in Amazon, at that time it is storing that you are going through this page, and next time when you go to Amazon, you will see recommendations that this is the product you should buy. Similarly, banks also does that. Obviously, bank does not do that by site and everything. We do monitor those things. But if we have sent you any sales pitch or something and you're going through it, you're going reading it, the customer is doing that. So to increase portfolio, how to target this specific customer? Because no entity wants to target let's say if there are 1 billion people in the world, even out of those 100 million are customers of a bank, not every customer will be very keen to invest. So then you have want to target only those people for which there is some probability. So those probabilities are captured by those models. Second is fraud detection. So there are so many frauds which keeps happening from a transactional perspective. ML models are very helpful in this because the way people do frauds keeps changing. So your model training or a machine learning models are known to learn from new strategies faster. So if I write a traditional code today that if a person takes an OTP from this person and do this and this transaction I'm getting this way, then don't process it. That is only one use case. I can do it by traditional approach. But let's say these fraud mechanisms and ways has changed so much. So if I talk about credit card fraud, the strategies has changed so much that we want the model to continuously learn that how people are attempting fraud so that we can detect the fraud. Third is customer retention. Bank at times also want to know that which customer is about to leave my bank, so they could track that what kind of activities they are currently doing with your bank, whether the amount is has been obsolete for so long or someone is withdrawing all the amount and things like that. So those are customer retention models. Then you have stock market forecasting models. Then you have regulation and cost savings. These are internal to banks, that if we want to build a machine learning models to reduce our cost, so we may put all the data and provide it to a model that tells that these are the factors which are costing us and this is the scenarios, and model can help us predict that in which areas we can save cost by what. Then we have customer centric pricing. If any of you have trade accounts, you may have noticed even without trade accounts in MF that sometimes relationship managers reach out to you with specific pricing to you as a customer. So that is not coming out of the blue. So much data is analyzed behind the scenes to give you an end customer pricing, because bank sees some profitability in connecting with you based on seeing how you're working out your financial portfolio. So these are some most popular examples for which bank do those things. Okay. Anything in this?
Ma'am, someone asked for the, you will also show the coding part, implementation
Uh,
part of the Python.
okay. So that was not the agenda given, but what I can do is maybe I can do some other session at the time, but I do have some coding. Okay. If you want to go through coding part, what I can suggest, and this is not related to my organization. So, okay. I run a channel, okay, and in this channel I have a course. This one, sorry, this is a course, complete course. So this contains all the coding which you have to do. So it takes through all the coding. If you want, I can take another session on this. So, and I have one or two courses here and there, so I can share that. So this will take you exactly how to write code line by line for each step for creating a model. So that is not the agenda for today if I'm wrong. So that's why I did not prepare any coding exercises. So we can cover that. We can talk about it.
Okay, ma'am.
Okay. See, my understanding and my agenda for today was to give you overall picture. I'm not sure because I was under the impression that the Python building and everything is already going through from 7 September. So that's why I'm trying to capture to help you understand that how exactly the end-to-end cycle runs. So uh, okay, let's complete this and I can take your inputs then where you actually want me to invest more time, and then we can do that. Okay. Next is, after we have done the use case understanding, then we have to do data processing and preparation. Now note two things here. Okay, let me pull everything. you may notice that I have divided these two things separately. I will tell you the reason why. When you process or prepare a data specifically for a machine learning pipeline or a machine learning model, there are two parts to it. The first part is you need raw data set. So let's say I have a net, let's say if I talk about, I don't take an example of, let's say I have a NetWest net banking, okay, application. In that net banking application, it has a application and a database behind, okay, OLTP database. Now I am trying to create a model using some data of that. Then I have another trade application, okay. Then I have another stock market application. All these systems, I have to pull out some data to create my model. So these are my raw data sets. So when I need that data to evaluate, I will pull that data into my data warehouse. So when I'm doing that, I will connect to all these systems. I will build pipelines. Now those pipelines can be batch and stream anything. So stream is something which you get continuously, and batch is something that I'm getting this data one time a day, two times a day, three times a day. So you load that data, then you process it, clean it, you apply some transformations and evaluate some KPIs which you need. Now this is part of your data engineering. But there is one more data thing which you do, and that thing you do in your model code. So this thing you do as a part of data engineering, and mostly data engineers do it for you. The second part comes which you do specific to your model. So let's say in your model, you want to replace null with average. So I have a row, I have customers, and I have how much deposit amount a customer maintain in its account in a month. Now some customer are not maintaining any. If I will provide null and I will provide the exact amounts, sometimes your model standard deviations does not work out as possible. So sometimes you need to provide averages whenever there are null, so that your standard deviation boundaries and your insets and your outsets can be calculated without any biases. Because if your one average will be too high, another will go down, then that will create problems. Similarly, you can also calculate outliers, that this is my 1% outlier, this is my 99% outlier. Similarly, you can do feature engineering. So these things are not part of data engineering. Okay. These things are done by data scientists when they are building the model, after they take this data which has been processed and prepared for them by data engineering team. So there are two parts to when you try to process and prepare data for a machine learning model. One part is availability of data, basic cleaning, basic transformation. And one part is specific to your model, that the model for which you are trying to build, you have a data set. Now how that data set is. If that data set is not right, sometimes let's say you are trying to tell a figure that whether this customer has a household account or not, then your value will be either 0 or either 1. In that case, if your model gets null data, it will create a third category. You don't want it to do that. What you want is that if the data is coming behind null, I want to replace it with 0, because that is specific to your use case. You will not do that replacement in data warehouse. So those things are done in your ML model code when you're writing that. So there are always two parts of data preparation in machine learning pipeline. One part by data engineering team and one part by the data scientist itself. Okay, I'll go back to that. Anything? Anyone want to know? Okay, I will then move to, yeah, somebody unmuted. Okay.
No, ma'am.
Okay, no issues. So we did two steps, okay? The first step is use case understanding and experimentation. Second step is data processing and preparation. The third step is model training, okay? So in model training, I have tried to add some insight with a traditional thing. If any one of you have ever thought that why should I train a model? So ideally, let's say if I'm trying to say that if I want to know that which of my customer, I have let's say 300 customers today, which do not have a credit card in one department, okay, belongs to one kind of account, savings account. I want to know how many of these will buy, whom should I call to? I can also write if an else program that, if this person is doing this, or if the balance is this, or if that person is keeping this, then let's go ahead and give him a call. Why I am going with model training? So traditional approach, let's say 6 years back from now, there was no model training popular. It existed, but it only existed in research programs. Companies were not using it. So this was a traditional approach. People were simply using business rules, that this is my business rule, if and but, on an experience scenario, and they are deriving insights, because analytics and insights exist from a long time. It's just the new machine learning insights have started coming now, but analytics existed previously as well. So why it changed? Why traditional approach stopped working for everyone? Why the world is moving so much towards ML? Because now the data points are increasing. Okay. Previously, when we used to apply data rules, they were like finite rules, which is the coder can code. Okay. Now these points have increased a lot. So the effort and the cost which will be spent to maintain and make changes on need basis and meeting business requirement is no longer acceptable. So we have to bring in machine learning to manage those things. So how machine learning is helping is, you provide all your data to a machine learning algorithm. You have to understand prior, according to your use case, which algorithm, or you can say which set of algorithms will be right for you. So it's not like that I have a use case data and I will push that data to any algorithm and it will start working and giving me results. No, if you are trying to do you need to know what kind of analysis you are doing. So let's say there is a one very popular analysis in market known as market basket analysis, and it is used in banks. It is also used in your normal life when you go to a V-Mart or a big bazaar. These components also do these analysis. So what they analyze is key which all components. So if a customer is coming to buy groceries for home, if he is picking, let's say, rice, along with rice, what he will pick. So this is known as market basket analysis, and there are specific set of algorithm. Similarly, a bank analyze that if a customer has bought this particular MF, what all are the products it can take in its basket. So what are the related products which can entice customer. So similarly, you need to know for your use case what kind of algorithms will be right, and from that set of algorithms, those algorithm studies are there, that if I'm trying to do one ML use case for a market basket thing, then I need these four algorithms to test. And then you pass on your data to those algorithms, and those algorithms has mathematical functions behind them which finds relationship between that data points, rather than you manually finding those. It learns some patterns from the data, and then it outputs a model which gives you model data file and a prediction algorithm. So that's how your model training works. I'm really sorry for how my PPT is running out of my hand in animation, but yeah, I will try to. So that's what your model training is. Your model training ends at a model file. Once you have a model output, that means you have trained your model. Okay. Once you have trained your model, then you will move to next step, that is evaluating a model. So as I said, it's not like you push data to any ML algorithm and your model is done. No. Sometimes that algorithm may not be right for your use case. The mathematics which is behind that particular algorithm is not good for finding data points for your use case. So we need to do a process known as model evaluation to know how well my model is predicting my classes after training and what is its performance. How we evaluate is different metrics. So if you may have heard about AUC metrics, if you may have heard about precision, recall, false positive, true positive, all those things. And if your metrics are coming fine on that trained model, then we evaluate it further by testing it on a new data set. So I will explain this in a paint. Wait. What I'm trying to say is, you have this data, okay? Assume that you have processed, prepared, and even the null and deviations, you have done everything. Now you push this data to a algorithm. When I say model, it's an algorithm. Okay, you provide this data to a algorithm. This algorithm runs over this data, and you also provide some attributes and parameters to that. Okay, that these are the attributes and these are the parameters with which my algorithm should process this data. Once you do that, what will happen is this process will simply give you a model file. Okay, format could be different. So if you talk about different Python, PySpark cloud, the model file format can be different, but all will give you one model file. This will be an object file. Once you have this file, your training has ended. Model training has ended. Now starts your model evaluation. How your model evaluation works is you take this model file and you apply matrix calculation on this. Now, when you apply matrix calculation, AUC, precision, recall, and other things, false positives, so many other things, weighted positives. There are many metrics. There are at least 112 matrices which are sometimes very popular according to the scenario. The basic ones which are calculated for all models are these. When you do that, it will give you a result. That result will be like my AUC is coming 0.75 of this model. What does that mean is that this model is predicting my outcome fine. Anything which is above 70 is considered good. But if it says that your AUC is coming 0.30, that means this model is not able to predict the outcome. Okay, so but this is not an only factor. All other things are also taken in consideration. So this process is called model evaluation. When you calculate these metrics over the model file you trained, this is called model evaluation. Then comes the last process in this particular deployment cycle, that is testing. Now, what does testing means and how it is different from evaluation is, evaluation means only calculating metrics and seeing how your model has performed. Basically calculating model performance. Now, testing means testing on a new data set. Why new data set? So when I was providing data to my model learned from it and my model gave me a 0.75 AUC. Okay. Think about it. Let's say you're teaching students in your class and they are learning from what you are teaching in class and they are scoring in exam 80%. Okay. Now, let's say you put one additional question in your question paper, which was not part of what you taught in exam, but it was part of your textbook. Okay. So you did not teach it in class, but it was there in the course module and you put it as an additional question. So then how your student performed on that new question actually tells their logical knowledge. They have not done, just by heart learning or something. Similar is the case for model. So you provided data to a model train itself, and model is giving you right outcome. What about if you give a new data to a model, which was not part of learning? Similar to if you are putting a new question in the exam paper, which was not part of class training. So how a student perform then? So that's what model testing is. Now you will run the same model on a new data, which was not part of training, so that you know that even if anything new comes towards model which was not part of training, model will still perform. Okay. Just a question out of the blue. Am I going too hi-fi in the concepts, or all of this is making sense to you? Is this helpful? Because my intention is not just to give you lecture till 12. I really want that all of this additional organization inputs help you. So if everything is going fine, you can let me know, or if you want me to, go in basics more rather than these concepts, I can do that. So if this is all okay with you guys.
Yes, ma'am.
Okay. Okay. So these are the three processes which sits in between, which are very specific to machine learning. Okay. And this starts after data processing. This is your model training. This is your evaluation, and this is your testing. Testing is very important to see whether this model is only training from the data we provided, or it can perform on a new data as well. Okay. Okay. Then we have model governance. Yeah.
Sorry, ma'am. Please increase the font size.
Oh, sorry. Okay. This I will have to write this again. Okay. PPT I will increase. This is small. Is this visible fine? This is working.
Yes, ma'am.
Okay. Now, once you have tested your model as a data scientist, okay, so data engineering team gives you all the data pipelines and build it for you. Then you basically did feature engineering, model build, model evaluation, model testing, and now as per you, there exists a model. Okay, so the model governance team, which was also involved in the starting initiation of the model, they will again come back in picture for auditing. Okay, so this is also a process, this is also a skill, this is also a role which is involved. These will be the people who will look after the versioning of these models, overall ownership of this model. So when a model is created, the ownership is not only with not the major ownership is not with data engineer or data scientist or the respective BA as well, or the salesperson. Okay, there is one single owner who controls that model, and that is a model governance owner. Okay, he is the owner who will simply dictate his terms and conditions or requirements to all of these people who are owner of implementation but not owner of model. So this person and this team will audit that these are the outcomes which has come out. They will decide on the versioning, they will decide on the tracking activities, they will look after the policies of the model, and they will decide how the access and the salesperson plan of action will be controlled. Okay. Then after model governance has given a go ahead that yes, this model is good to go ahead in production. Then you go ahead and do model deployment. Now model deployment is simply not like that I have created a model and that model file I will take and I will deploy it on the production environment or another environments. No, you have to package that model. You have to package the dependencies. You have to package the connection requirement. You have to package the data readability points from where you're connecting the new data and all. You have to package the model object, and then you have to deploy it to the environment. That is how you do the deployment. Once the deployment is done, then comes the pipelines, which are also part of deployment itself. Why pipeline and why not only deployment? See, think about it. Uh, think about from the perspective that these models are generic day-to-day part of people's life, right? The engineers who are working inside. Now we need to have a smooth process to deploy, to orchestrate, to create the flow of these models, that how the model will be going from one step to next step, to address and capture the metadata points when this model is orchestrating. And we also may want to schedule that when this event happens, run this model. When this event happens, then do this. When this event happens, then trigger this model. So all of those things, or I want to run it on different multiple environments because I have, let's say, 10 developers working on this. So in actual organization, the model deployment is not the last step. So you will see it written at various places that deploy the model and it's finished. No, you have to have pipelines in place. And there comes the ML engineers. This is a third role. So data engineers did the data part, data scientists did the ML part. ML engineer is an additional role which overlaps data scientist in some way, that they will have to do engineering from an ML ops or ML engineering perspective, that these entire cycle of running and orchestrating and capturing the inputs can be running smoothly with monitoring in production. So those steps are involved in a pipeline. Now, the famous pipelines which you may hear is CI/CD pipelines of Git, and there are GUI tools as well. So if you may have heard, Data IQ is really getting popular these days because Data IQ address these problems. It gives you a pipeline flow, workflow, which tells you how eventually end to end your model is running. Okay. Once your model is productionized and everything is enabled, then that is not the case that once you have built a model, it's done and dusted. No, you will have to continuously monitor that model. Continuous monitoring means that whenever a new data set comes, okay, so if a model is running daily on new data, some customer data or some trade data is coming daily, then on that model is running. So daily we monitor the performance of the model in a new data set. We log it, we track it, and if we see the performance is degrading now because some new scenarios have started coming in data and my model is no longer able to capture or cope up with that, it is no longer the right way to deal with that, maybe I need to do more hyper tuning, then those things are identified as a part of process known as continuous monitoring and logging. So if there is a data drift on the data which is coming new, okay, like suddenly when last year corona happened, a lot of scenarios came in new which were not there. People stopped, the people who were using credit card at a full flow, they stopped using it because they were not going out, all travels were being cancelled. Second scenario was you want to know that how many people have lost their job. You can track from their banking accounts. If they're not getting salary anymore, it seems like they have lost their job. So you may want to know that if has any loan credibility or anything in the bank that you want to track. So all those things comes in picture at that time. These, so a model can give you performance based on the data it is coming. So if suddenly something happens or even in something drastic does not happen, the data set changes, you need a continuous monitoring on that model so that your outcomes are there. And in this continuous monitoring, when the system sees that the model is not performing up to the mark, then model governance team also comes in picture. Okay. And the last step which happens is, so the salesperson, so if I'm doing a target sales model, okay, let's say if I'm doing two target sales model, one is I want to give customers credit card and one is I want to reach out to a customer for doing trade in the products I am promoting. Okay. Then from my side, a salesperson is calling these customers. Okay. When that salesperson and that salesperson got the lead from our ML model, that my ML model predicts that call these 15 people with these suggestions. Okay. When that salesperson makes that call, okay, and the customer says no, I don't want it. Salesperson captures that feedback. Okay, that feedback goes back to initial pipeline that even though model predicted 80% that this customer will take a credit card, the customer has said no, that will go back. Then those feedback parameters and circumstances will be analyzed whether this was a one-off scenario because some customer could be just pissed and didn't want it, and it could be a genuine scenario that model predicted wrong. So then those feedback parameters and circumstances are analyzed, and that learning is incorporated back to model training, and then better outcomes are tried to be produced. So this is also a continuous feedback loop which comes from the end business employees who are actually doing actions on the model outputs which we are doing as an engineering team, which we are providing to them as an engineering practice. So this is how the overall, if I come back to this flow, this is the overall flow with which a model is working in a banking organization. And I can say even for non-banking, these things will remain the same. Sorry. Okay. Anyone want to ask anything? Go through any step, understand logically what is happening. Was this all explainable? Now, do you get what each step is trying to do? What kind of roles which are available? Let me remove the animation. What kind of roles which are available? Anything like that? Okay. No question on any steps. Any okay? I'm assuming that everything is explainable. Okay. Any question on pipelines, cloud, governance, or testing? Okay. 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 Then I will add some more information regarding to this. Okay. Let me just one second. Okay. Now let me cover one more thing. That one more thing here important is whatever you're seeing here. Okay. This can be done by programming. This can be done by auto machine learning modules which are coming these days. This can be done by different machine learning services which are provided these days. So if I take a non-cloud example or if I take a cloud example, how these steps will differ, what is the significance, why people are doing this or why people are not going with approach one or approach two. So when you do with non-cloud, okay, let's say you are simply creating a notebook, Jupyter notebook, in your local, you have a SQL server database in your local, and you have a dummy data set, and you tried and you create a model and it is working fine for you. Now, this is just one approach looking at it. Or when you're talking about a data, it could be a flat file as well. So you don't even need a database. But in practical, when these models are built in organizations for larger data sets and larger use cases, that is not the case. They are built on a very high volume. That's why those factor and databases come in picture. But what is the significance? Why people are moving toward cloud? When this machine learning was happening 3 years back on premise servers. So, by on premise servers, I mean Unix servers, Windows servers, which an organization has inside. They are not in cloud, they are hosted and installed inside network of an organization. Then, what was happening was this data, because machine learning, to learn from a data that how a customer is going to behave or how a credit scoring is going to behave, you need a lot of history to understand how it has behaved in past. Then you need a lot of data volume. Now your traditional on-premise systems, they don't deal with too much volume. You will always get some error like the RAM is overutilized or CPU is running overutilized and all those things. That's why to assess and get better predictions, better outputs, these people are moving towards cloud. Okay, because moving towards cloud gives you the flexibility and scalability to get higher volume of data. Okay, now I will show you not a coding example, but I will show you Google Cloud Services, how it works there. Okay. So this is the Google Cloud platform. Okay, I am hoping my screen share is working on this as well. I share to entire desktop, right? Yeah. Okay. So this is a Google Cloud platform. Okay, this is very simple to get into. Anyone who has a Gmail ID, they can get into a Google Cloud platform. You don't even when these are so. This is the same platform is set up inside an organization. This is one way to do ML. So if you will go and check for Google Cloud services, you will find a lot of services in cloud, and similarly, there will be these services will be there in Azure as well, AWS as well, and other things. So if I go to machine learning, see this artificial intelligence and machine learning area. So you see natural language is also there. You see document AI is also there, recommendations AI. So these are managed services. Okay, what managed services means, that you will go and do auto ML. Auto ML means I will just provide the data. Auto machine learning provided by Google in itself derived that which algorithm is right for my use case and will give me prediction. I can validate that prediction and then I can tell auto ML to revise that. Okay. Most companies at this time, I am talking about banking, they are not going to auto ML as of now, because we want a certain control over data, in the sense that we only understand our data. Auto ML will not be able to understand my data columns as I understand it. So what they do is they do it by programming. Okay. Now that programming can be, I'm logged in with which ID? I don't have access. Sorry. It's okay. So when they do by programming, they will have to create those clusters and stuff and do programming. So like you were talking about Python programming. So if you want to today go to Google, and you say that I want to write a Python program, what you can do is you don't need to set up anything in your local system. You need to go to AI notebooks. Okay. You don't even need to create a cluster. I will not even go to creation of cluster. You can simply create a AI notebook instance, and once you create it, so if you want to write a model in Python, you can do that. If you want to write a TensorFlow, you can do that. If you want to write a PyTorch, you want to write a R model, some companies are writing in R as well. So in no organization there is a specific language in which the models are written. It can be Python as well, it can be R as well, it can be Spark as well. I will tell you why it differs. See, Python has its own machine learning library. R has its own machine learning library. Sometimes the things Python have, some models are generic, like classification model you will find in Python as well, R as well, Spark as well. But not everything is generic. Sometimes some use case or some algorithm is available in R, which is not available in Python, and it is giving me better results. So then I want to go for R for that model. So similarly, want to do anything, you can simply create a notebook from here. If you want to write a Python model, just simply go and create. If you want, you can do advanced option and customize this Python notebook which will be created. I can select maybe 7.5 GB RAM and I can create it. Once this is created, I can simply start writing my models from here. I don't need to do anything. That is the significance of cloud. If I do this thing in my local laptop or in my local machine, I need to set up pip install notebook. I need to do Python install. I need to set up the data file in my system. I need to use my CPU and my RAM for it. Okay. And those, everything of those has limitations and time going in. When you do all that setup on an on-premise machine or on a local machine or everything, there has a cost of time and of resources. And if your data is huge, the machine will run out of memory or RAM or disk, and you will not get the required output. What value cloud is adding, for which people are going, is because of three reasons. One is you don't need to maintain infrastructure. I'm not maintaining infrastructure. Right now, assume, let's say you wanted to install Python, you want to work on Python. You need a laptop, right? You need to install Python on your machine. Similarly, if an organization wants to write a Python code, they need to have a machine, whether Unix based, Windows based. So they need to invest in that. They need to maintain that machine from security perspective, from maintenance perspective, from Windows patching, Windows upgrade. So when you use cloud, I want to write Python code. I did not need to do anything. I just went and I created an AI notebook. So I don't need to maintain this server which is getting created. I need not to maintain the Python installation. I don't need to do anything. So the first headache which organization gets rid of is the infrastructure limitations and infrastructure time which is spent in. The second thing which you are getting is this, that you can scale this. If your data on which you are going to write a Python code, it's in terabytes, then when you create an instance, at that time you can select how much machine type, RAM, how much persistence you need by going in advanced option. You can tell that. So you can't do that on your laptop. If you want to, let's say, deal with 3 GB data tomorrow and your current laptop has 4 GB RAM, you need to spend money permanently on your laptop and get that. Similarly, if an organization have their own machines, they need to do that. But in cloud, I can do those things by simply selecting these things. And I can delete this once my work is done. So even if I choose a more RAM machine to process my model, I can delete this and can get rid of once my model is done. I don't need to permanently buy it. So these are the advantages because of which these things are moving to cloud, because people want to spend time on building model rather than dealing with infrastructure issues, time issues, scaling issues, or installation issues. You won't believe how much time it used to go previously 5 years back because somebody installed some Python pip package which is incompatible, and some changes had been made to config which is not working. So all those things are being unlisted and unutilized, and then people are moving to cloud. Right now, all the popular banks, I can vouch for Morgan Stanley, NetWest, Goldman Sachs, Mashreq, everyone is moving to clouds, although to different clouds. Okay, so Morgan Stanley is on AWS, Mashreq is on Azure right now, NetWest is working in Google Cloud. So all those kind of things. So I just created this and I will show it to you opening that how cloud is adding value to this particular pipeline we are trying to process. See, you can simply start working on a notebook from here. And I did no installation. I did not created any machine. I did not needed anything. This is the power of cloud. Now, this is one service which cloud provides. That is, it is providing you ease, it is providing you scalability, it is providing you comfort. Okay. Another thing which cloud provides is additional services along with that. And those services are known as managed services, which are quietly becoming popular with this process. What those managed services does is that you don't even need to create this. You just give us your Python code. We will automatically create this. We will automatically decide from the volume. We will automatically decide the algorithm and we will give you an output. That is, these services are called managed services. So if I take an example of a very basic job, I think batch jobs everyone knows, batch operating jobs. If you have to write or run a batch job, you need a Windows machine, right? Then you will go to Windows scheduler and you will schedule your batch file to run as a job that every night load this data. So basically you need a machine, you need a processor, and you need a program. What does managed service do? That you don't need to give any of this. You just give your code, we will create and manage the machine, we will create and do other things, we will take care of the processing, we will take care of the jobs monitoring. You just give us the code and tell us what you want from it. So those are the managed services. So if I can show you one example of that is Cloud Composer is a very good example of that. Cloud Composer. Yeah, this one. So if you have ever heard about Airflow, any of you, it's a very popular Apache Airflow services. So when you use Apache Airflow, it is used for scheduling jobs in a directed acyclic graph, DAGs. Okay. So when you right now traditionally do it, you create a Unix server, you install Airflow over it, you set up your Airflow configs, and then you run your jobs. Okay, and then you also have to manage the server. Now Google Cloud allows that. You can create a compute engine VM machine, you can install Airflow over it, and you can set up that. But what Google Cloud says, I will give you one additional service. This additional service is known as composer. What you need to do is you create an environment, and after that you don't need to set up airflow or anything or do anything. You just give me your DAG, that is your Python code, and I will do the rest myself. But these services are expensive in the sense they cost more than the compute engine machine. So to do anything in cloud, whether it's Azure or AWS, you will get two options, whether for model training, model testing, or anything. You will get managed services as well, and you will get VM instances. Go to compute engine, create a machine, install anything on that machine, and do anything. So if you create any Unix machine, install any software for a matter, even Skype or anything, you can use that machine. So that option is also there in every cloud. You can create any machine with any kind of configuration. But what cloud is additionally providing you, what about you don't want to manage that as well? You just want to run your code. Then you use my managed services. I will charge you more for it, but I will give you complete comfort so that you spend your time only in these steps and not worrying about infrastructure. So that's why all of this has moved to cloud these days. You will find some on-premise implementation of model deployment, and they are in on-premise system, but everyone is going to in next 3 years by 23 or by 24. Each of these things will be cloud in 80% of the organizations. So what I'm trying to say eventually out of all this is, from my perspective or from what I have seen how industry changing over the past few years and how where it is going is, just learning writing a model is not just a machine learning skill. When you talk about that, what things a student can also invest, because everybody will not have interest in just creating a model. So getting into machine learning is not just about creating a model. There are multiple interest areas and multiple roles and multiple opportunities like cloud and on-premise and other differences, which can be useful and can be taken by respective to interest. So not everybody needs to just be a data scientist to do machine learning. You can do ML engineering as well. That will incorporate a lot of machine learning portion apart from dealing with algorithms. Because an ML engineer has to take care of ML ops. Okay. Anything, any questions in terms of clouds or anything else? Okay. Okay. Okay, yeah. So security aspects in cloud computing. So yeah. So let me show it to you actually.
Ma'am, some
Yeah.
questions from participant side. Uh, One question is, how fraud detection is taken care of?
Okay. I will first answer this. What about security aspect? Then the fraud detection. So the security aspect part. See, in every cloud platform, there is a portion related to networking. Okay. So these are managed by networking team. So that is another role, network engineers. Okay. These network engineers are the ones, VPC networks and other firewalls, routes, shared VPC. Whenever any organization move to cloud, the first thing which is set up, that is, these are these things. Okay. These things controls your firewalls, control the IP addresses, and provide virtual private networks for us to work in along with keys. So for example, if I want to create a Hadoop cluster, okay, and I want to make sure that this cluster nobody will be able to access from outside. So how I can do this? There is a section for security. In every component you will go, whether you are creating a compute engine, whether you are creating a warehouse table, it will be this. So the first thing is, even if any organization does not add their specific security, then also Google provides their own encryption key. Okay, so nobody, a hacker cannot access it, but still people goes with customer managed encryption key. So these are the encryption keys which has all the VPC networks and settings and encryption settings for the data or the processing which is getting encrypted. Along with that, we have the options to select the VPC network. So whenever any organization networking team will add virtual private networks for you, all cloud, whenever you do something, that option will come here to select that virtual private network and that subnetwork. So anything which is controlled and created with that virtual private network, that will control that your cluster will stay inside that virtual private, okay, that private network. So all of these are network settings which are applied whenever we use any service inside cloud, and they are created and managed by the security teams, and they are handled by different security services which cloud allows. Similarly, you have IAM. Now, one is infrastructure security that you do by networking, by controlling your ports, by controlling your firewalls, by controlling your uh, firewalls, ports, and private networks. But another thing is access control. That which person should have an access for this particular thing and which person should not. So then in all three clouds, you have identity access management. From here, you control which person, which service account, which service will have access to which permissions. So these are the permissions you define, and that person and that service account can only perform those roles which permissions are provided. So the permissions are handled at three levels. The first level Google provide by default. So this is my personal account right now. Okay, this is not my NetWest banking account. Even if I create a cloud storage here, or even if I create a cluster here, you guys will not be able to access it. Although I don't have any organization VPC network, you will not be able to access it because Google is providing me one level of default protection. Okay, so that is available to everyone. Second is, another level of protection is provided by network. That is, you control how your infrastructure will be accessed, how your systems will be accessed. And third level of control is identity access management. Even if someone accesses your infrastructure to delete your data or to copy your data, the permission should be there. Those permissions are managed by identity access and management. So there are three levels of security. First level by Google default. And when I say Google default, consider it like your Google Drive. So nobody can access your Google Drive till they have your Gmail ID password, right? Similarly, anything you use in Google Cloud, Google is providing you one level of default security. Second is your network layer. And third is your identity layer. So even if you can access my project, let's say you did something and I did not set up proper networking and you access my project, and you think that I will go to the warehouse of BigQuery and I will delete the data for this customer. No, you will not be able to do that because identity access management has not provided permission to you. So there are 3 4 layers of controls in terms of security which works, and along with that data encryption comes. So if I go to data warehouse of Google Cloud, so BigQuery is the data warehouse of Google Cloud. Okay, so if you go to this and you open any table, you will see that there is a, if I create a table, basically this one I have not created here. So if I open this data set and I create a table, see, in this advanced option you have encryption option. So even if you don't specify your encryption, Google provides you one default level of encryption. Anyways, although people goes with this, in organization we don't use this, but even if we don't use this, we have one level of Google encryption, and this is over security. Security is separate, encryption is separate. Security is someone accessing your server. Encryption is when the data is flowing over network, is this flowing in your raw state or the data is encrypted? So there also there is an additional layer of security. So these are all the parameters which are set to make sure that data is secure. Does that answer your question? Okay.
Yes, ma'am. And then next question is, does these projects giving return on investment?
Sorry, there was one before you asked, before something related to fraud. One question was pending. I forgot what was the question.
Yes, ma'am. How fraud detection is taken care of?
Yeah. So see, there are so many internal things which happens in bank, and obviously I cannot share it all. But what I can say in crux is that whatever activity, whatever transactions are happening. So let's say you are doing a net banking transaction. You goes and you transfer a payment, and after 15-20, if it's NEFT, after 15 minutes of IMPS straightforward, you see that the amount is credited to another person. So to you, from a end user, it looks like that you just transfer and it went to another person. No, that is not the case. That payment goes from at least 6 to 7 systems in between before that is processed. Okay, and there are so many things which bank does in between to ensure that this payment is not going to some terrorist organization, or this is not a fraud, this is not a shell company at the end or something like that. So many things happen which we obviously don't tell to customers, but those happen because those are regulations which banks has to go through. So that payment at least go through minimum 5 systems in between for validation and for other checks and other things to manage that. If you talk about credit card detection, which is not a regular thing like a savings account, that can happen anytime. So whenever you do any credit card transaction, those are part of streaming pipelines. Okay, streaming pipelines means as soon as a customer did swipe or did anything, I should get that in my ML model. Okay, immediately. I can't wait for a night that in the night I will process this data to my ML model and that will tell me whether this was fraud or anything. Sometimes, let's say you are traveling outside the country and you regularly don't travel. If you are doing, let's say, 30,000 transaction as you landed in Dubai and you have never traveled before, your credit history or your pattern is not going out and spending like this, then you will get an immediate call on your account because the ML model will generate a notification for the end customer sales team that this is a fraud. Please check with customer. I'm this has happened. Maybe some with some of you it may happen. So it's your pattern. If you are a person who don't spend more than 20,000 in a month on a credit card, and suddenly you start spending 1 lakh rupees, model will notice that. So it's a pattern which is built with your behavior, how you are behaving, and plus the history of fraud which is coming. So customer also reports some frauds to us, which let's say model missed or model could not cater at that time. So those frauds are recorded, how that happened, what was the transaction. So model also has a huge history of that these kind of frauds or these transactions or these types are there. So all those history and learning is also incorporated, and then the outcomes are derived. So that's how in different areas fraud detections are done. So there are compliance and regulations and different systems. In fact, we even check whether when you enter a payee nickname, when you do a transaction. So if, before we transfer the amount to the payee, we also check whether that nickname matches to the end customer name fully or not. So that may not, that particular check may not always essentially stop the payment, but it will raise a flag